Module 5, Session 3. Session 3 will cover Learning Outcome 3.3.5, Solving Problems in 2D and 3D using the Sine and Cosine Rule, Part 2. Learning Outcome 3.3.5, Solving Problems in 2D and 3D using the Sine and Cosine Rule, Part 2. Now that we have revised the sine and cosine rules, let's move on to more complicated examples. In Level 4, students need to be able to solve problems in both 2 dimensions and 3 dimensions. It is useful to revise some terminology that can help students. Guide them to identify the angles of elevation and depression correctly. This is important for success with 2D and 3D problems. These angles are always measured from the horizontal, and they are always measured from an observer's viewpoint upwards, elevation, or downwards, depression. Tell students they should draw in a dotted horizontal line on their sketch if needed to help them identify which angle they are dealing with. Let's watch a lecturer first with some tips on solving 3D problems and then solving a 3D problem using the sine rule, followed by solving a 3D problem using the cosine rule and trig ratios.
When we consider 3D problems, we first need to highlight that 3D is a combination of two types of triangles. You have right angle triangles and you have non-right angle triangles. And now the tools in solving right angle triangles, it's 2. If they want the sizes of sides, you're going to use Pythagoras, or depending on what is given, you're going to use trigonometric ratios by applying silly old hen kickles and heckles till old age. In other words, you need to know the meaning of sine, need to know the meaning of cos, you need to know the meaning of tan, because the relationships might be opposite adjacent, which means tan. The relationships might be opposite hypotenuse, which means sine. The relationships might be adjacent hypotenuse, which means cos. And with the aid of that, you can solve either a side or angle. That is now for right angle triangles. And then in the case of the non-right angle triangles, you're going to use either the sine rule, which is referred to as the rule of opposites. In other words, opposites. And when are you going to use the sine rule? When 2 angles and a side is given, or when 2 sides and an angle is given. Or, secondly, you can either use the cos rule. And when are you going to use the cos rule? When 3 sides are given, or when 2 sides and an included, very important here, included. In other words, those 2 sides that are given, the angle that are given are formed by those 2 given sides. And those are the tools, in short, that you're going to use and can use to solve any 3D question. But what is important is, as a tip, take out that specific triangle and apply that knowledge. And focus on it alone, one at a time. And then you'll be able to sort it out. CP is a tower perpendicular to a horizontal plane ABC. ABP is a triangular plane with its base AB on ground level and its vertex at P. Beta is an angle from the ground level to AP. Alpha is the angle between AB and AP in the plane of triangle ABP. Determine the height of the tower, which is X. Now let's fill in this information onto the diagram so that we can see what do we have here, because the way the diagram looks now, it means nothing. Alpha is 70 degrees. You can see there it's indicated in red, and I can just indicate there 70 degrees. Beta, that part is 20 degrees, so I will put in there the 20 degrees. And obviously delta here is 60 degrees, so I will just highlight it there and then indicate there 60 degrees. Now it makes more sense. Because if I then look now at triangle ABP, I think you all agree that if you look at the interior angles here immediately, I can now calculate angle P, because it's going to be alpha plus delta plus angle P. That must add up to 180 degrees. So I will start first by writing down the triangle that I'm focusing on. I'm going to say in triangle ABP. Angle P is equal to 180 degrees minus the sum of, obviously, alpha plus delta. Oh, sorry for drawing it so funny. Which is equal to 180 degrees minus alpha is 70 and delta is 60, and we got a nice answer of 50 degrees. So immediately I can then indicate there that angle there is equal to 50 degrees. Then they give me a value of A. A is equal to 10 meters. Now, in order to find the height of this tower, which forms part of a right angle triangle, obviously I need to find the value of AP, because AP is a common side. AP forms part of triangle PAC, but AP also forms part of the non-triangle PAB. So I'm going to now find the value of AP by using this non-right angled triangle. Let me just draw that sketch here, the way it looks there, more or less. Right. I'm having A here, which is equal to 10. Then I'm having, this is A, this is P. I'm having P here, which is equal to 50. And I'm also having this value here, which is equal to 70 degrees. And this is B. What do we have here? Very easy from this sketch to see two angles and a side. And it's an opposite side. We're going to obviously use the rule of opposites, which is the sine rule. So we're going to now illustrate, use sine rule. Always start from the side that you want. This is obviously 60 degrees. We always will start from the side that you want. We want AP, so we're going to say AP over. There's AP, the opposite side. There is sine of, we're going to use that B, because I'm focusing now on my triangle here, is equal to then A, small a, over sine of P. So let's make AP the subject of the formula and then substitute. AP will therefore be equal to small a sine of B over sine of P. and that is equal to 10 sine of 60 over sine of p sine of 50, and if you punch that into your calculator, you will get a value of 11.3 meters for AP. After we have solved AP, now we can move to our right angle triangle. Let me just sketch it here. Our right angle triangle. There's 90 degrees. This is my X value. There is P. There is A. And obviously there is C. And this angle here is 20 degrees. And I have the value for AP now as 11.3 meters. Now I can find A. 20 degrees opposite over hypotenuse. Obviously, we're going to make use of sine. So we're going to say, okay, sine of 20 degrees is equal to opposite, which is x, over hypotenuse, which is 11.3. Therefore, x will be equal to 11.3 sine of 20 degrees. And I'm having a nice answer of 3.865 meters. Let's look at this three-dimensional problem that we have here in front of us. A, N, and L. A, N, and L are points in the same horizontal plane. ML is a vertical pole with a length of 4 meters. AL is equal to 5 meters, and the angle ALN is equal to 115 degrees. And the angle of elevation of M from N is 40 degrees. And the first question here is calculate the length of LN and round off the answer to 1 decimal place. LN is a common side. It is common to triangle ALN, which is non-right angled, but it is also common to triangle MLN, which is a right-angled triangle. In order to solve LN, we will then consider looking at the right-angled triangle. So let's take out that right-angled triangle and let's draw it here. M, L, which is 90 degrees, and N, which is 40 degrees. And size of ML is 4 meters. For a right angle triangle, we're going to use the concept of solving of triangles. So we will use any one of these 3 ratios, either sine, or we're going to use cos, or we're going to use tan. And now we're going to look at what do we have. Always start from what do you want. We want LN, which is the adjacent side of that 40 degrees. In other words, sine falls out of the bus. It will be any one of these 2. Now we're going to look at that side in relation to that angle. That side is right opposite that angle. So opposite adjacent, obviously, we're going to use the ratio of tan. We can straight away then start now by writing tan of 40 degrees is equal to opposite, which is the 4 meters, over adjacent, which is ln. Then now we're going to use ln, the subject of the formula. That is equal to 4 over tan of 40. And we have a nice answer of 4,8 meters. Take note, 1 decimal place, 1 decimal place. And that is the answer for number 1. Let's look at question number 2. Question number 2 is, we need to find the length of AN. Now AN also here forms part of triangle, the bigger one, AMN, but it also forms part of the smaller triangle here, ALN, which means AN is right opposite that 115 degrees. So in this instance, let's look at what do we have now. Let's draw the non-right angle triangle. We have A, we have N, we have L, we have the 115 degrees here, we have the 5 meters here, and we have just calculated the 4,8 meters there. In other words, we have a non-right angle triangle, and what is given here? 2 sides and an included angle. Why included angle? Because that 115 degrees is formed by the 2 sides. And when you have 2 sides and an included angle, you will use the cosine rule. So in order to find AN, we're going to use the cos rule. So let's start. Going to consider these triangles. We're focusing on this triangle, so I don't need to rewrite triangle ALN. I'm just going to start straight away. What does the cosine rule entails? The cosine rule you will find on your formula sheet on formula number 18. It is the side that I want, AN squared, is equal to, right, the sum of those 2 sides squared, which is 5 squared plus the other side, 4.8 squared, minus 2 times the product of those 2 sides, and then cos of that 115 degrees. So you people can see we have used everything. That side squared plus this side squared minus 2 times the product of that cos of that angle. In other words, now you can just substitute. That gives you 25 plus 4.8 squared, it's 23.04. And then if you calculate everything here together, minus, take note, that gives you a minus 20.286. Why do you get a minus there? Because cos of 115 is negative in quadrant number 2. And AN squared, therefore, will be equal to 68,326. Now we can find the value of AN. AN is equal to the square root of 68.326. And that gives me, they said, round off the answer to the nearest meter. This will give you 8 something, which means we will get 8 meters approximately to the nearest meters.
Now work in groups to do this activity. There are 2 3D problems to solve. Think about how you would help your students with these problems as you work through them. Let's start with question 1. Promise is standing at point P on level ground. She can see 2 buildings with heights AC and BD. The bases of the buildings C and D are in the same horizontal plane. From P, the angle of elevation to A is 23 degrees and to B is 18 degrees. Promise is 18 meters away from the base of building AC. The height of BD is 7 meters. Now work through questions A to C. And now, please complete question 2. An observer, A, stands at point A. His angle of elevation to the top of a tower is 40 degrees. The tower is north 20 degrees east of his observation point. Another observer, B, is 30 meters due west and found the tower to be north 40 degrees east. Calculate the height of the tower if T is the foot of the tower. Remember to think about how you would help students with this type of problem as you work. That brings us to the end of the trigonometry section and to the end of topic 3. Thank you for your hard work. This was a big and important section of work.